On this one, we have question 6. It reads as follows. A spontaneous electrochemical cell, it's set up under standard conditions using nickel and silver. So we have Ni there. So that Ni there, it's for nickel. And then the Ag, it's silver, right? So these were the electrodes that were used there in that electrochemical cell reaction. So the electrochemical cell. It's not like the other questions where you have the electrochemical cell drawn and then you just have to analyze and all that, right? So on this one here, everything was just written down that we have this cell and it's a spontaneous cell. So for the fact that it's spontaneous, so this mainly means that this reaction, this cell can operate on its own without the help of a source, right? So it doesn't need a source for this one to occur, and this is what we expected for a galvanic cell. It doesn't need a source, it can occur. So the reaction just takes place on its own. So reaction takes place on its own. Didn't need a source. And that's the spontaneous. So now choose one word from the statement above that indicates that the cell is a galvanic cell. So it looks like we didn't know at first whether this was electrolytic or a galvanic cell, right? But there's just a keyword here that tells us that this is a galvanic cell, and that keyword is spontaneous. So the fact that we are given that the cell is spontaneous meaning that it can occur on its own, it can only be a galvanic cell and not electrolytic cell. So a spontaneous electrochemical cell, it's a galvanic cell. And then a non-spontaneous, which is going to be the electrolytic cell. Now, we chose the word, and now we go there. Now they say define the following galvanic cell. What is a galvanic cell? So remember, a galvanic cell, if someone asks you what is a galvanic cell, you'll say that it's a cell that converts. So it's a cell that converts chemical energy to electrical energy. So the type of cell that converts chemical energy to electrical energy. Whereas if they ask you electrolytic cell, what is an electrolytic cell? That one converts electrical to chemical. So this one converts chemical to electrical. That's galvanic. It converts chemical to electrical. So 6.2.2, electrolyte. What is electrolyte? So electrolyte, it's a substance. We say it's a substance. So it's that solution. It's a substance solution that conducts electricity So it conducts what? Electricity through the movement of ions. So it's a substance solution that conducts electricity through the movement of the ions. That is an electrolyte. I made a mistake there, the spelling. It has to be electrolyte, right? So, my bad. 6.3. What energy conversion takes place in the cell? I feel like it's a repetition of a question because we've already looked at the type of cell. We've already identified that this is a galvanic cell. So I think this question should be very easy for us here because they're just still asking for energy conversion, and whereas we've already spoken about it, we've already mentioned it in the definition of a galvanic cell. So this is mainly just the chemical. You're just going to write chemical energy here, chemical energy to electrical energy, to electrical energy. That is a galvanic cell. It converts chemical energy to electrical energy. 6.4. Which one of the electrode is the cathode? So I kind of like this question because we were not told anything. We just have nickel. We just know the substances that here we've got nickel. And if you look at it, it's nickel versus Ag, right? So I'm going to try my best to explain this, right? So you have nickel here. So nickel is versus Ag. We don't know which one is going to be, which one of the electrode is the cathode. Remember, we recall NOx, red cat, right? So it's very much necessary to recall NOx, red cat. So this NOx, red cat tells us that in the anode, oxidation takes place. In the anode, oxidation takes place, and then reduction takes place in the cathode. So the red there, it's a reduction, and then cat, it's for the cathode. Cathode. Now, which one here? We don't have to guess this, but we are going to make use of the 4B table. It's Ni versus Ag, which is silver. Now we make use of the table. We use the table that starts with lithium in it. So we're just going to go down in this table. So which one do we see first between Ag and nickel? So you will notice that we still don't see anything there, but if we continue to go down, we should see something. I think we see silver first. Silver, it's over there. Let me highlight silver. There's silver there. We see silver. Oh, I think there's also nickel up there. So I think nickel is actually the one that we see first. Right, so let me highlight nickel, the different color, just to be able to see the difference. So we see nickel, it's up there, and then the silver, it's down there. So the one that we see first on the lithium table, I want you guys to recall that it undergoes oxidation. So the one that we see first undergoes oxidation. So it means that nickel, we see nickel first, and we know that nickel, we see it first, so it will be undergoing oxidation, and then silver is undergoing reduction. So this mainly means that according to what we recalled the NOx red cat, you will see that the NOx red cat, this helps us to tell that, oh, okay, which one is going to be in the anode and which one is going to be in the cathode. So the anode, we have oxidation, reduction is in the cathode, right? So this mainly means that between Ag and nickel, the question was asking us which one is associated with the cathode. It's silver. You can agree with me that that's going to be silver because it's below nickel, right? So for that question there, it's going to be silver because the reduction takes place in the cathode. Reduction takes place in the cathode. Let me write the cathode spelling. Cathode. And then oxidation takes place in the anode. So let's just quickly go there and answer this question. It was 6.4. Now we will write silver Ag. 6.4. Don't have to write both, but we've already figured it out. It's actually silver. You can write Ag or you can write silver. Meaning that in the anode is nickel. Now 6.5, write down the half cell reaction at the cathode. Now we know that it's silver that is at the cathode, but for us to write the half cell reaction, we will make use of the 4B table, and then we will see that silver is down there, which is the cathode, and there's Ag plus. So we are going to copy down that reaction as it is. Why? Because all these reactions here are written in their standard reduction. So they are written in their standard reduction form. So meaning that all these reactions are written in the standard reduction form. If we are required to write a reduction reaction, we're just going to copy it as it is there. So we know that in reduction, the cathode there, it's silver. So meaning that we're expecting a reaction that looks like this for that silver. So you just copy it as it is, but you don't put the two arrows, you put one forward arrow there. Right, that is the reduction reaction taking place in that cell. 6.5, we're moving. Let me write it down here. We're going to write down this is Ag plus E minus, and this will be Ag, silver. Right, good. Let's now move on to the next one. 6.6. The question is saying that we need to calculate the EMF, right? We're calculating the EMF of the cell under the standard conditions. So for us to do this question, to calculate the EMF of the cell under the standard conditions for 3 to 4 marks, we mainly just have to make use of the formula, right? So obviously, I guess we've identified that the other cell there is reduction and the other cell is oxidation. I think this thing moved, yeah. I think it's perfect like this. Yes, we've already figured out that the other half cell, it's oxidation, and the other half cell is reduction. So meaning that because we know that this one here is, we're just going to make use of the formula here. So which formula do we use here? So I think if you go to the formula sheet, you will see that we have a formula to calculate the E cell naught, right? We have a lot of options here. And also, I think the best option that we can also use the first formula there that tells us that the E cell naught can be calculated. The E cell naught can be calculated from the E of the cathode minus the E of the anode. And you'll agree with me that we already identified what's in the cathode, and what's in the cathode was that Ag, and what's in the anode was the nickel. So we just need to go and get the difference between those two. We look at their EMFs. Right, so let's just quickly go there. So which numbers are we going to make use of? We'll make use of this negative 0, this numbers here. We have negative negative 0.27 and positive 0.80. So let's go and calculate that. So this is going to be E cell. If I can write it here quickly. So the E cell not would be the E of the cathode. Which one is the cathode? It's the one down there, the Ag. And then minus E anode. So this was going to be positive 0.80 volt minus negative 0.27. We're just going to make use of the calculator here. Then if I do that, you will notice that this is, it's going to be 0.80 minus negative 0.27. And what is the answer? The answer is 1.07 volts. This is the answer for the E cell for those two half cell reactions. You can see that the cathode is the silver and the nickel, it's the anode. .7. We can move on now. Now, when we go to 6.7, the question is just saying that we need to write down the cell notation for the above for the above cell. So this is a very simple question to do, but I noticed that students find it a little bit challenging because now you just have to recall that now. But normally what I advise is that I advise people to recall that we have to start with the anode, then we draw the salt bridge, then we go to the cathode. So anode, salt bridge, cathode. Then after that, now we're going to go to the anode. We identify what is the electrode in the anode. Then after that, we are going to identify what is the electrolyte, the solution, the electrolyte. And then after that, we do the salt bridge. Then we find the electrolyte. We go to the cathode now, but instead of starting with the electrode, we're just going to start with the electrolyte, and then now we go to the electrode. Right, good. What is the anode? The anode, remember, they said the anode was silver, right? So the silver in the anode, we have, no, it's not silver, I think it's nickel, right? So let's just go and check it on the 4B table just to be sure. Yes, or the anode is the nickel, right? Do you see that? The anode is the nickel. So the anode is over there, that's the nickel. It's over there. And then what is the electrode? What is the electrolyte? What is the electrode and the electrolyte? So the electrode is going to be nickel. And then what is the electrolyte? Electrolyte is the solution. So the solution is going to be the ion, which is Ni2+. And then now we go to the cathode. The cathode there. We ask ourselves, what is the electrode? And you'll figure out that the electrode here, it's the silver Ag. And then the electrolyte. It's Ag+. It's the ion. Yes. So we just look at this, right? You would see that we have the ions, and mostly these ions are just are in aqueous form, right? So these ions are our electrolytes, the Ni2+ and the Ag+. These ones with the ions are just going to be our electrolyte, right? And these ones without the ions, the Ni and the Ag, would be our electrode. So now let's go and quickly write that down. We said we looked at the anode, then what is the electrolyte in the anode? The electrolyte in the anode is going to be nickel. It's nickel. You can write that it's in solid form, and you can write nickel 2+. That is the electrolyte. It's in aqueous form, salt bridge. You are done with the anode. Now you go to the cathode. Instead of starting with the electrode, but you're going to start with the electrolyte. So you mean that you'll start with the ion Ag+, and then you write aqueous solution. So aqueous solution, it means that it's in a solution form. And then electrode, you're just going to write Ag, which is in solid form. And there we have our cell notation. We've answered the question. So if we just quickly look at what we do here, we identify which one is the anode, then we put in the electrode. We say electrode, electrolyte. Then we identify the cathode. We write what? The electrolyte and the electrode. And then there we have the electrode, which is in solid form, and the electrolytes, they are all in aqueous form, and they have got the signs there. They've got the 2 pluses and the pluses there. Those are our electrolyte. And if you notice closely, our electrode are in solid form, and they are on the outermost. They are on the outermost, right? So we are done with that question. Now let's move on to 6.7. Right? Oh, 6.7, that's the question we were doing. I'm sorry. So let's move on to question 8. Now, question 8.1. They're saying worldwide interest in renewable energy technologies continues to see strong growth each year, right? So the outlook remains positive, especially for alternative solar energy technology applications. Now, here they just wanted us to name one alternative energy source. Remember, alternative energy source. So the alternative, just any one alternative energy source, we can talk about biodiesel. Biodiesel. You can talk about fuel cell energy, or you can talk about nuclear energy. Nuclear energy. They just want the the alternative energy sources besides solar energy, right? So I think we all know solar energy. There's biodiesel, there's nuclear energy, there's also wave energy, you can name them. I think there's many of them, but just know how to respond to this question when they ask you those even wind energy. Know how to respond to these questions. 6.8.2, name 3 uses of photovoltaic cell. Right, they want 3 uses of the photovoltaic cell. So we know we've got a lot of uses for that photo. We can talk about pump energy. So pump water. You can pump water. Pump water from the ground. So you pump water from underground. What you can also do, you can light up at night. Light up at night. And another thing is you can charge the batteries. You can use it to charge batteries, right? So I think it's perfectly fine with this one. So you'll notice that we managed to discuss all these questions, even though we took time, but it's for your own benefit so that you can learn. We are trying to do as much as we can, but obviously we can't cover everything in one video. And I'm just hoping to see you on the next coming videos. And this brings us to the end of this video. Thank you and bye bye.